Hey everyone! In the previous section, we played around with the OpenAI API, examining message roles and key LLM parameters like temperature, token limit, and the streaming feature. Now that we have the foundations for creating chatbots, it's time to utilize the OpenAI API through LangChain. But before we start coding, let's conceptually discuss the LangChain framework. As mentioned in previous lessons, LangChain allows the creation of stateful, context-aware, and reasoning LLM-powered applications. To make this quite difficult task possible, LangChain's developers have divided it into several integration components, each responsible for individual subtasks. The first two components of an LLM-powered application are the model input and model output, falling under the umbrella term Model I/O. The module includes a large language model, a prompt, an example selector, and an output parser. Let me include prompt templates here and begin our discussion with prompts and prompt templates. As you know, prompts are the questions and instructions we pass to a model in text form. For example, I've recently adopted a dog. Could you suggest some dog names? Prompt templates, in turn, provide an abstraction to prompts, making them reusable. Continuing the same example, imagine the word dog becomes a placeholder for any pet. We can then pass the word dog as an input, and the model will return a list of possible dog names. It's now easy to ask for possible cat names by passing only the word cat. Nice! Such prompt abstractions are especially handy whenever we want to provide a model with examples to learn from, a technique called few-shot prompting. But more on this in upcoming lessons. So that's how we deal with model inputs. What about model outputs? As you've seen, the output from a model comes in the form of an assistant role message. This format is unsuitable for output intended for a Python script that accepts pandas data frame objects, or language models that require XML inputs, such as those by Anthropic. This is where output parsers come into play. In a section dedicated to output parsers, we'll discuss ones that parse outputs into strings, datetime objects, or comma-separated lists. All right. So the model input-output module comprises a prompt, a model, and an output parser. You can also see example selectors listed on the infographic. They fall beyond this course's scope. Next up is the retrieval module. As we've previously discussed, retrievers are components we can add to our chatbots to make them context-aware. That is, we can strategically feed them external or proprietary information so that they can answer questions on data they haven't trained on. As you can see, several components make this possible: document loader, text splitter, embedding model, vector store, and retriever. This is the order in which we'll discuss them in the course. Ultimately, we'll create a chatbot to answer questions on 365's Introduction to Data and Data Science course. The third and final module is agent tooling, which allows reasoning chatbots to be created. These chatbots can choose among different tools and their order of execution to solve various tasks. You can also see that tools for specific tasks can be combined to form toolkits. Although our course won't cover toolkits, it's beneficial to know that you can create them or use ones integrated into LangChain. So far, so good, everyone. Another component of the LangChain framework is the specific protocol known as LangChain Expression Language that links the three modules. It forms a significant portion of our course. This subject is best learned by doing, therefore I will not cover it further in this lesson. One last part of the framework we'll demonstrate in the course is the templates, which are pre-implemented prompt templates that have proven helpful for specific tasks. And with that, we exhaust the modules covered in this course. What's left are the Langsmith platform and the LangServe libraries, which we briefly mentioned earlier. The former is responsible for a product's observability, while the latter is for the deployment. Regarding the documentation, two main web pages will tremendously help you in the learning process. The first is LangChain's documentation page, where you can find plenty of tutorials, how-to guides, a conceptual guide, and a list of integrations. It's a valuable resource that you're encouraged to read and reread. The second is the library's API reference. This essential aspect of programming documents every function, class, and method. We'll refer to this resource many times throughout our journey. I think we're good to go. I've told you so much about LangChain that I'm sure you're thinking, all right, let's get to the coding part already. Well, here it is. Hey everyone! I'm thrilled to welcome you to this section of the course where our LangChain journey begins. By the end of this section, we'll have our very first LangChain mini project completed, implementing a helpful but sarcastic chatbot. To achieve this, we'll take the following steps. First, we'll get acquainted with the Chat OpenAI class in LangChain, which supports OpenAI's chat models. Then we'll discuss in detail the different types of messages LangChain offers and the value of using prompt templates. After that, we'll give an overview of the most crucial concept in LangChain, namely the chain. Later in the course, we'll further unfold the chain implementation in the LangChain expression language section. I hope you're excited to dive into this adventure as we explore the magic of the LangChain framework. Code along with me. Our first task is to install the LangChain library within the LangChain environment. To do this, you first need to open your Anaconda prompt. Activate the LangChain environment we created. Then pip install the LangChain library. Note that the installation might take a minute, so be patient. Once the installation is complete, pip install the LangChain OpenAI library necessary for utilizing LangChain's OpenAI integration. Excellent! Now create a fresh Jupyter notebook, and while doing so, remember to use the LangChain environment kernel. For simplicity, ensure the .env file is in the same directory as the notebook. As previously demonstrated, we can use IPython's magic commands to set the API key as an environment variable. Recall that you had to load the .env extension and apply the .env magic command. Then run the cell. This line of code is sufficient for LangChain to locate the required environment variable. Next, include the following import. From LangChain OpenAI, .chatModels, import Chat OpenAI. Execute the cell and create a variable called chat. Set it to an instance of the Chat OpenAI class. This class offers a parameter called modelName, which holds the name of the desired one. For this demonstration, I'll utilize OpenAI's GPT-4 chat model, but you can use any supported ones listed on their website. All right, since this class uses OpenAI's API, we can employ the seed parameter to ensure you and I obtain similar responses. But upon examining the documentation, we find that seed is not listed. Therefore, we cannot directly use it as an argument in our code. If we try to do so, we, unsurprisingly, hit an error informing us that seed is not a default parameter, but rather transferred to model keyword arguments. Indeed, additional parameters like this one are added with the help of another one called model keyword arguments. It expects a dictionary, which in our case would store a key value pair with the key being seed, and the value being any integer. To obtain results similar to mine, use a seed value of 365. You can add other parameters by specifying them as key value pairs within the same dictionary. Another handy parameter the OpenAI integration offers is temperature, which, recall, controls the level of randomness in the responses, with a lower number corresponding to more deterministic answers. I'll set its value to 0. Let's give this chatbot a go. Create a variable called response. Following an equal sign, type chat, and then apply the invoke method, specifying a prompt as an argument. As you progress through the course, you'll find that invoke is a chief method in LangChain. We'll gradually build up our knowledge of this method until we reach the LangChain expression language section, where its functionality will become more apparent. For now, it's essential to know that it accepts various inputs, including a string-type object containing the user prompt. I'll go with the following. I've recently adopted a dog. Could you suggest some dog names? A quick note here. Occasionally, throughout the course, you'll find me writing prompts within triple quotes, rather than single or double. Doing so allows for seamlessly moving text to a new line when the prompt becomes too lengthy. Another convenient feature includes using single and double quotation marks as part of the prompt without terminating the string. Alternatively, you can also use triple double quotes. Apply whichever you prefer. Having clarified that, we're now ready to run the cell. This operation might take a few seconds, especially the first time. Let's see what kind of object the response variable is. It's an instance of the AI message class, one we'll discuss in greater detail soon in this section. For now, it's important to note that this object includes a parameter called content, which stores the response as a string. We can, therefore, append .content to the expression above. Finally, use the print function to neatly format the content. Great! We have an exhaustive list of categorized dog name suggestions, but I think we can all agree that this is quite a lengthy response. Let's limit the maximum number of completion tokens to, for example, 100. Redefine the chat object and invoke it again to create a new response. Displaying the response variable, we see that the content is much shorter this time. All right, very good so far. We've taken our first steps in exploring the LangChain library. In the next lesson, we'll introduce the different types of chat messages that LangChain offers. I'll see you in a bit. Welcome back, everyone. In the previous lesson, we constructed a simple chatbot using the ChatOpenAI class in LangChain. To invoke the model, we passed a single string containing our request and got an AI message object in return. But LangChain enables us to invoke chat models in several other ways. In this lesson, we'll dig a bit deeper into the system and human roles, which act like the system and user roles we encountered in the OpenAI API. To refresh your memory, these message roles specify the message's sender. A system message directs the model's behavior, such as emulating a teenager, an academic, or a philosopher. For instance, you can find an example on OpenAI's webpage, like this. You are Marv, a chatbot that reluctantly answers questions with sarcastic responses. On the other hand, human messages are messages sent by the user, questions or requests that require a response from the model. An example of such would be, I've recently adopted a dog. Could you suggest some dog names? Having revised the concepts, let's outline the strategy for this lesson. We'll first define our chat model. Then we'll create one instance of LangChain's human message class and one of a system message type. And finally, we'll learn how to invoke the chat model with both messages simultaneously and study the output. Let's get started. I've prepared a new notebook with pre-configured code that includes setting the API key as an environment variable, importing the ChatOpenAI class, and initializing a ChatOpenAI object with such parameters as model name, model keyword arguments, temperature, and maximum number of completion tokens. Feel free to pause the lesson and implement the code at your own pace. After that, run all cells in order. Once you're ready, enter the second cell of the notebook and make the following new imports. From LangChain core, .messages, import system message and human message. Rerun the cell. At the bottom of the notebook, create a variable called messageHuman and set it as an instance of the human message class. A parameter called content allows us to write our request to the model as a string. I'll go with the familiar message. I've recently adopted a dog. Can you suggest some dog names? Let's assign a variable named response as chat.invoke. We invoked the chat object using a single string in the previous lesson, But the invoke method also accepts another type of input, a list of chat messages. That is, among others, system or human messages. We'll use a list as an argument to hold multiple entries, initially storing just the message human object. Run the code in the cell. After a brief pause, it's complete. The result is the recognizable AI message object with the model's response. Extract the content feature and use the print function to enhance readability. Great! Let's now give our chatbot the familiar sarcastic twist by employing the system message class. Define a new variable, call it message system, associated with an instance of the system message class. Include the familiar message. You are Marv, a chatbot that reluctantly answers questions with sarcastic responses. Let's rerun the cell. Redefine the response variable so that the list inside the invoke method includes the system message first and the human message second. Execute the cell. Once the process is complete, print out the content of the response variable. And there we have it, the familiar sarcastic tone. All right, everyone, great job. We'll continue this series on chat messages in the next lesson, where we'll experiment with the AI message object. See you there. Hey, everyone. Welcome back to this series of lessons where we discuss and experiment with LangChain's chat messages. Last time, we demonstrated the purpose of a system and a human message, storing chatbot instructions and user requests respectively. In this lesson, we'll learn how to incorporate another type of chat message, the AI message. Recall that you've already encountered it as an assistant role message in OpenAI's API. Remember that our response variables were also instances of LangChain's AI message class. So, AI messages are ones generated by the model. They can also be used in few-shot prompting. Few-shot prompting is a technique whereby we give the model a set of example responses to learn from, so that it later generates responses that align better with our expectations. And that's precisely the use case we'll demonstrate in this lesson. Let's start coding, shall we? I've chosen to utilize the notebook from our last session. So if you have it within arm's reach, please create a copy and open it now to bypass redoing the code. We'll apply only minor tweaks. First, remove the system message class from the list of imports. Then the system message instance, which instructs the bot to be sarcastic. And lastly, exclude this object from the invoke method's argument. This way, we won't tell the model how to behave. Instead, we'll teach it to give sarcastic responses through the few-shot prompting technique. Note that, in general, it's ideal to have both a system message and a fair number of examples for optimal model performance. What we're doing here is only demonstrating the effect of few-shot prompting. All right. Next, navigate to the cell with imports and include the AI message class from LangChain's messages module. Run all cells in order. Upon executing the print statement, we see that the model has responded politely and has suggested suitable dog names, constricted by the number of completion tokens. But let's now teach it how to be sarcastic. To do that, let's first rename the messageHuman variable by appending dog to the title. Now we'll need a second variable called messageAIDog. Set it equal to AI message and prepare the content parameter. It'll store an example response to the human request above, sarcastically suggesting good dog names. For time efficiency, you can use the last lesson's notebook to generate the responses rather than devising them independently. That's what I did. And I'll copy-paste the response from the model. Of course, you're always welcome to unleash your sarcastic personality and come up with answers using your imagination. Since we've already prepared an answer to the question on charming dog names, we need a new human message to pass to the model. Copy-paste the human message we already have and change the end of its name from dog to cat. Analogously, change the content as follows. I've recently adopted a cat. Could you suggest some cat names? Execute the cell. Organize the list with 3 items in this order. The initial inquiry about dog names, followed by the AI's example response, and concluding with another query regarding cat names. Run the process. When done, print out the content of the response variable. We have a new suggestion, this time relevant to cats. The model seems to have missed our intention for a sarcastic tone. Perhaps additional examples could clarify. Let's explore further. Copy-paste the AI message instance that we already have. Change the name to _cat. Use the last lesson's model to generate a sarcastic response. And copy-paste the result into your notebook. As before, we now need to create a new question for the chatbot. Copy-paste either human message, and this time locate the pet keyword inside the object's name and the string, and change it to fish. All right. Rerun the cell. Append the AI cat message and the human fish message to the list. Let's execute this cell, and finally, print out the result. There we have it, the sarcastic tone we were after. Of course, providing the model with more examples will improve its responses even further, but remember that this comes at the cost of using up more prompt tokens. I think we're advancing quite well, but we still have a lot to explore. In the next lesson, we'll discuss how to create abstractions for our prompts and make them reusable with the help of chat prompt templates. I'll catch you later. Welcome back. We've explored and tested LangChain's Chat OpenAI class. We meticulously examined the invoke method, noting that it accepts a string or a list of chat messages when used on Chat OpenAI object. The chat messages we analyzed included a system message storing instructions for the model, a human message storing the user's questions or request, and an AI message storing the model's or example responses. These message objects proved very useful, but have a significant drawback. They are not reusable. The developers at LangChain have, therefore, implemented prompt abstractions called chat prompt templates, allowing for the reuse of system, human, and AI messages. Before jumping into chat prompt templates, however, discussing prompt templates constructed from simple strings rather than chat messages will be helpful. So let's get started. Open a clean notebook in the LangChain environment. Begin by defining a variable called template. You'll notice some developers adhere to the convention of using all caps for string templates. Let's apply this convention to our code as well. Following an equals sign, write a set of triple quotes. Enter a new line, for clarity, and start the template by writing the word system, followed by a colon. On a new line, type the word description within a set of braces. This serves as a placeholder for the description of the character the chatbot will be required to impersonate. Proceed with the template by entering human, then continue, I've recently adopted a, and include pet. Next ask, could you suggest some, also including pet. Conclude the template with names and a question mark. This outlines our string template design. Next, we'll use this string to create a prompt template object. Enter a new cell at the beginning of the notebook and import the required class, namely, from LangChain core, .prompts, import, prompt template. Great. Move to the end of the notebook. In a new line, define a variable called prompt template and assign it to an instance of the target class. Let's now invoke a method called fromTemplate to create an object from the same class using the string template we created. Set the method's template parameter equal to the object defined above. Let's examine the result. As expected, the object is an instance of the prompt template class. A parameter called input variables stores all keywords we defined earlier, namely pet and description. Subsequently, the string object is also retained. One convenient feature of the prompt template class is that it implements the familiar invoke method. It expects a dictionary and returns a prompt value object. In contrast, Chat OpenAI's invoke method accepted a single string or a list of chat messages and returned a chat message object. All right. Create a variable called prompt value and set it equal to promptTemplate.invoke. As we now know, this method expects a dictionary where we specify the values of the input variables. Let the first key value pair have description as a key and set its value as follows. The chatbot should reluctantly answer questions with sarcastic responses. As a key to the second key value pair, set the word pet and assign dog as the corresponding value. Run the cell and examine the prompt value object. It represents an instance of the string prompt value class. It includes a parameter called text, which we can extract and print out for readability. We find the description placeholder has been substituted with the appropriate chatbot description, and the pet placeholder is replaced by the word dog. Excellent! So, let's recap the process. First, we created a string template containing input variables defined within a set of braces. Second, we created a prompt template instance using the string defined. Third, we applied the invoke method, specifying the values of both input variables, which resulted in a prompt value object storing the filled-in template. All right, everyone, great job so far. In the next lesson, we'll take it up a notch and discuss chat prompt templates. Additionally, we'll show that Chat OpenAI's invoke method can also handle prompt value class instances, beyond single strings and lists of chat messages. This ability becomes crucial later in the course as we link objects, using the output of one as the input for another. I'm looking forward to seeing you there. Welcome back, everyone. Now that you understand the mechanics behind prompt templates and prompt values, you have all the tools to understand how chat prompt templates work. Open a fresh Jupyter notebook, and let's begin. On the screen, you can see I've prepared a familiar code, setting up the API key as an environment variable, importing all necessary classes, and defining the chat model with all known parameters. I've also introduced several new classes, including system message, human message, and chat prompt template. Following the steps from the previous lesson, let's create two string templates, one for the system and another for the human message prompt template class. Create a new variable, call it template system, all caps, and set it equal to the input variable description. Then create another object called template human and set it equal to the familiar question, making sure to introduce pet as an input variable. Great! It's time to define our first chat message prompt template. Let's call it message template system and assign it an instance of the system message prompt template class. Follow the expression with the familiar from template method accessed through the dot notation. Within a set of parentheses, set the template parameter equal to the first string we defined. Let's study this object. It includes a single parameter called prompt, defined as an instance of the prompt template class that stores the input variables and the string template. Analogously, let's define an object of type human message prompt template. Copy-paste the definition of the last variable, change its name to read message template human, adjust the class name accordingly, and apply the relevant string template. Rerun the cell and display the variable. As expected, we find that the prompt parameter is initialized with an instance of the prompt template class. Its input variable's parameter equals a list storing the keyword pet, and the template parameter keeps the human string template defined previously. Very well. Let's now combine both message prompt templates in a single chat prompt template. Initialize a new variable called chat template with an instance of the chat prompt template class. Let's then apply a class method called fromMessages, which, as the documentation reads, creates a chat prompt template from a variety of message formats. Within a set of parentheses, define a list storing our system and human message prompt templates. Run the cell and display the variable. The method returns an instance of the specified class with two parameters displayed. The first is input variables, which stores the keywords from both message prompt templates. The second one is messages, storing both objects in a list. Excellent! Now recall from our previous discussion that the next step in the sequence is applying the invoke method on this chat prompt template object, specifying the values of each keyword. Create a new variable called chat value, analogous to prompt value from the last lesson, and set it equal to chatTemplate.invoke. Use the last lesson's notebook to copy-paste the familiar dictionary, which sets the values of the input variables, description, and pet. Run the cell and study the chat value object. This is an instance of the chat prompt value class, derived from the already familiar prompt value class. It contains a parameter called messages, where the placeholders have been filled. Instances of the system and human message classes now substitute the system and human message prompt templates. All right, excellent work so far. It's time we feed this chat value object to a chat model. Like before, create a variable called response and set it equal to chat.invoke. Recall that ChatOpenAI's invoke method accepts not only a single string or a list of chat messages, but also instances of the prompt value class. So, invoke the chat model, setting chat value as an argument. As expected, the result is an AI message object with the parameter content storing the response. All right, let's end the lesson with a summary of our implementation and key observations that will prove essential later in the course. We first defined one system and one human string template. Next, utilizing the FromTemplate method, we created an instance of the system and the human message prompt template classes. In the following step, a chat prompt template object combines these two instances. We invoked it, passing a dictionary as an argument. The dictionary sets each input variable to its corresponding value. The result was a chat prompt value object, which we passed as an argument to ChatOpenAI's invoke method to create a response in the form of an AI message. So, I hope you're starting to see the pattern here. The output of one invoke method serves as the input to another. Understanding this concept will be the stepping stone toward understanding how chains in LangChain work, a discussion we've reserved for the LCEL section later in this course. I'm sure you appreciate the convenience of working with prompt templates. We'll further alleviate this knowledge in the next lesson by discussing few-shot prompt templates. Can't wait to see you there! Hey everyone! So far in this section, we've learned how to create and use ChatOpenAI objects, how to employ system, human, and AI messages, how prompt templates work, and how they differ from chat prompt templates. Additionally, we observed that the output of one invoke method could serve as the argument to another. More specifically, the chat value object resulting from the invocation of a chat prompt template instance could serve as an argument to the invoke method of a ChatOpenAI object. Let's now revisit the lesson where we created two human-AI message pairs, which taught the model to answer questions sarcastically. We refer to this as few-shot prompting, giving the model a couple of examples to learn from. This would be a zero-shot prompting if we provided no examples to the model. I think we can all agree that this previous implementation of few-shot prompting was somewhat clumsy. Our approach was to define a separate human-AI messages pair for each example. This needlessly cluttered the code and is, evidently, hardly scalable. In this lesson, we'll utilize a class called few-shot chat message prompt template and recreate the same example, but implement it much cleaner and more compactly. Let's get to work. I've opened a new Jupyter notebook with the familiar code pre-implemented. In addition to the known chat, human message, and AI message prompt template classes, I've also added the few-shot chat message prompt template class from the prompts module. The name is quite a mouthful, but more importantly, descriptive. Once you've implemented the code and run all cells, define two new string templates, human and AI. The string human template is already familiar to you, so I'll just copy-paste the string. The AI template will consist only of an input variable, which I'll call response. Next, following the known procedure, create one human and one AI message prompt template. Combine both objects into a chat prompt template instance, which I'll call example template. Abiding by its name, this object will serve as the blueprint for our human-AI example pairs. So far, so good. What follows is creating a list of dictionaries, which I'll call examples, with each dictionary storing the values for a single example. Let's create the first dictionary in the list. Set the pet key to the value dog, and the response key to the example AI response. I'll copy-paste the string from the old notebook. Now define analogously the second dictionary. Set the key to the input variable pet and the corresponding value to cat. Assign the keyword response to the example AI response, which I'll copy-paste again. Excellent. Now on the agenda is combining the chat prompt template object with the examples list in a single variable. For that, we'll employ the class responsible for few-shot templates. In a new cell, do as follows. Define a variable called few-shot prompt. Make it an instance of the few-shot chat message prompt template class. Set the parameter examples equal to the examples list, and the parameter example prompt to the example template object. Run the cell. The next step is to create an object called chat template and set its class to chat prompt template. Apply the from messages method and pass as an argument a list storing the few-shot prompt object and the message template human object. All right, we combined all examples from the list with an additional human message template that will be filled in once the user invokes chat template. This will become much clearer with a demonstration, so let's create a variable called chatValue and set it equal to chatTemplate.invoke and pass a dictionary as an argument with the key pet being assigned the value rabbit. Examine the chatValue object. It keeps a single parameter, messages, which is a list of human and AI message objects. Since this output is somewhat challenging to read, we can print out the content of each message with the help of a for loop. Notice that I've used the type parameter that all chat messages possess, which helps distinguish between human and AI messages. All right, let's examine the output. The first 4 messages are part of the few-shot examples, and the 5th comes from the human message template. Very good. All that's left is to invoke a chat model, passing this chat value object as an argument. We obtained an excellent selection of possible rabbit names. I hope you can now appreciate how straightforward it is to pass more examples. Let's demonstrate. You simply need to add a new dictionary to the list of examples, redefine the few-shot prompt and the chat template objects, invoke chat template to redefine the chat value object, and invoke the chat model to generate an even better response because of the increased number of examples. This approach avoids defining a series of message objects and instead uses only a handful of prompt templates. Neat, isn't it? This concludes our lesson on prompting. Looking forward to meeting you in the next section.